In this video, we'll cover graphs of functions with combined transformations. We can find points and sketch the graphs of functions that are changed by a combination of transformations. Translations are the easiest transformations to use since they shift the graph while keeping it the same size and shape. Dilutions change the size and shape. On your screen, you'll see some sort of steps to graphing functions with combined transformations. So method 1 here is you state the original function. So on your screen you also see we have y equals x minus 2 squared minus 5. That has an original function of a parabola, which is y equals x squared. We then can list our transformations, what is occurring. We know there's a horizontal translation of 2 units to the right, given by the negative 2 in the equation. And there's a vertical translation of 5 units down, which is seen by the minus 5 in the equation. Step 3 would be then to find the transformed functions. For example, we know that y equals x squared has a vertex at 0, 0. So the transformed function vertex occurs at 0 plus 2 to get the new x coordinate and 0 minus 5 to get the new y coordinate. As there's no dilations, the graph keeps the same shape, so sketching this transformed graph is quite easy. You just can move the vertex and then sketch it. If you want a more accurate graph, you could find the y and x intercepts, which will be a lot more accurate than just sketching the vertex. The second method that you could use is to create a table of values for the original graph and then apply a single transformation to the table of values. And you continue this until each transformation has been applied. Remember, you have to complete either horizontal or vertical transformations first. I tend to go with horizontal transformations first and then complete your vertical transformations. A side note as well, you should be doing dilations first because they involve multiplication, and then completing any translations, which is usually adding or subtracting. After you've done this, you can then plot the coordinates to graph the transformed function. So here we can start with a question. Sketch the graph of a transformed function if the parabola y equals x squared is transformed into x plus 2 squared plus 4. So what we can do here, because this is parabola, we know that the vertex of the original is at 0, 0. So our transformed vertex will be at 0 plus 2, 0 plus 4, 2, 4. So on your screen you can see y equals x squared. We know that the transformed function will occur, it has a vertex here, and then it will be a parabola coming up like this. Again, if you want to be more accurate, you can find your x and y intercepts and put them in. You could alternatively do a table of values for a range of coordinates on here for your original parabola, and then complete the changes like we did there with the vertex to each of these to get an accurate graph. Sketch the graph of the transformed function if the parabola y equals x cubed is transformed. So here we have a y equals x cubed function. We know that our transformation will be y equals x minus 2 cubed minus 3. Again, these are just translations, so we can put them in now. So I'm going to do my horizontal translations and move each point down 2. To the right, sorry, 2. That goes there. So this would be our y equals x minus 2 cubed. We still need to do our minus 3, so I'll do that in a different color, which means we're moving everything down 3 spots. So our blue will be y equals x minus 2 cubed minus 3. Obviously, it's better to be a little bit more accurate in the way you draw these lines than I have here, but you can do each transformation as one until you ultimately get to your final transformation. Given each function, sketch the graph of the transform. So here we have y equals fx, and we need to sketch y equals 3 fx minus 1. So to begin, we will start with our 3 out the front, so we have a vertical dilation. So that means each point has been multiplied by 3. Like that. And then we could sketch a line going through it. Alright, so that would be our y equals 3fx. But we have a minus 1 there, so we have a horizontal translation to the right 1 unit. So our blue line now moves to the right 1 unit. So our green would be y equals 3f bracket x minus 1.